Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 374. Guess number is higher or lower. We are playing a guess game. The game is as follow. I pick a number from 1 to n. Okay, you have to guess which number I picked. Okay, every time you guess wrong, I will tell you whether the number is picked is higher or lower. Okay, but they will give a AP. Okay, that means they will give a function that function is unknown except that name of function and the parameters. We want to pass some argument to that function, then we want to get some value, then we want to check whether some uh, we want to process after we have got the return value of that function. Let's just see here. If the function returns -1, it means the number we have guessed is larger than the what pick value. Okay, that is we guessed number is larger. Okay, if the guess number is smaller, it returns what 1. If the guessed number is equal to the pick, then it returns what 0. Fine. So let's see an example. See here, if n is equal to 10 and the pick is equal to 6, the pick is not visible to us. It is not given as an input. Okay, they will only give this n and then that function. We want to put some values and we want to return some return the pick value. Okay, the guessed number. Fine. If it is 10, okay, what is it range? This range from 1 to 10, right? They have clearly stated here at the question 1 to n. Okay, so it is what 1 to 10. Now for 1, what should I get the value which is returned by that function? 1 is less than the pick, right? 1 is less than the pick, so we get what 1. We get what 1. Okay, now 2 is less than the pick, we will get what 1. Now can you imagine how the values are uh, created by that function? Let's take this function. Let's take this example. It will be more clear. This is what the example. Okay, if we give 1 to that function, it will return what 1, 2, 1, then 3, 1, up to 5, it will return 1. But at 6, it will return what 0, because it is equal, right? But at 7 to 10, it will return what -1. But carefully observe this. If I put whether this 1 is equal to 0, then I will get what, whether I want to return it or not. I will get right. Now just for example, see here. I just call that function by using a value called 1. Okay, 1. Whether that function of 1 is 0, no. Now whether the function of 2 is 0, no. 3, no. 4, no. 5, no. 6, yes, it is 0. It is 0. So it should be my output. Clear? Clear? Now what is the time complexity? What's the time complexity? I can say the time complexity is O of n, because we are traversing entire array, right? And then what is the space complexity? It is O of 1. Fine. Now let's take another example and we can see what is another approach. So it is the first approach, linear time approach. Okay, now or second approach. Just see here, it is what in descending order, right? In descending order. So I can say if it is descending order, it is sorted, right? If it is sorted, I can say minus h, minus h. Can I use minus h? Fine. Let's check so that we get idea whether we can use minus h or not. Just I wrote that array. Then what are the values? For 1, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Fine. Okay. Now let's begin the binary search approach. What is the first step of binary search approach? We will place low pointer and upper limit, lower limit and upper limit. Now what is a mid pointer? That's a mid value. It is 1 plus 10, it is 11. 11 by 2, it is what? 5. So here is my mid pointer. Okay, here is my mid pointer. Now I'm going to check whether this mid pointer is 1 or 0 or -1. Now what is the case in this scenario? What is the case? I can say the mid pointer is what? 1, right? Let me write here. The mid value is what? Is equal to 1. If it is 1, what should I do? What should I do? Just observe. If I move left side, whether I get 0, or if I move right side, I will get 0. I want to move right side, right? I want to move right side so that I can get this 0, right? right? So I want to move where? I want to move this low pointer to mid plus 1, mid plus 1. So strike out, move here, fine. Now again, now what is the mid pointer now? 6 plus 10, it is 16, 16 by 2, it is 8. Now mid pointer is here. Now what is the mid value? I can say the mid value is what? The mid value is equal to what? Minus 1. If it is minus 1, where should I go? I should go towards right, or I should go towards left. I should go towards left. Just imagine 0 is here, right? Here. So I want to go where? I want to go towards left side. So take this low upper bound and place here. Fine. Now again, what's the mid value? 6 plus 7, it is 13. 13 by 2, it is 6 again. So here is my mid. Now, sorry, I haven't wrote here. Fine. Now what is the case? Mid value is equal to 0. Yes, at that time I want to what? I want to do a return what? Mid value, because 0 is the answer, right? So we have written. So what are the cases? When it is equal to 1, and when it is equal to minus 1, and when it is equal to 0. That's all. That's all about the binary search approach. Okay. Let us analyze the time complexity. So what is the time complexity for this binary search approach? I can say it is O of log m. And then what is space complexity? We haven't used any extra space, so it is what? O of 1 constant, right? So this is what the time complexity and space complexity analysis. Now let's see about the coding part. Yes, see here. First of all, L is equal to 0 and U is equal to n. Okay, that is when n is equal to 10, then U is equal to 10, right? Upper bound. Now, while L is less than or equal to U, mid is equal to L plus U minus L divided by 10 divided by 2. Just I am finding the midpoint. Then, if guess of mid, guess is what? Guess is the function, the DAP. Guess is the function name. So, guess of mid. If the mid value is 0, if the mid value is 0, then what should I do? I should return what? Mid. If the guessed value is equal to 1, what should I do? I should do I should move towards right side, because that is the possibility of finding a 0 towards right side. So that I am moving the L to mid plus 1. Otherwise, I want to go towards left side. So U is equal to mid minus 1. Understand? Surely there will be 0, right? Surely there will be 0. That's why one return statement is enough for Python, but for C++, you have to give a dummy return statement here. Okay, so let's submit it. Yes, it is submitted successfully, but still we can give like G is equal to guess of mid. Okay, then take this and give G, and also take this. Why? Because we are calling that function 2 times, right? Instead of that, in this approach, we have called the function only one time. It is somewhat better. Okay, so let me submit it. So, but both have the time complexity as log n, but still, okay, fine. Thank you.